Hello all, so let's continue with a new problem, and from this problem what we will do is we will learn an important pattern called prefix sum. So let me just remove this as of now, and what we will do is first let's read the problem. So we are given a binary array, so it's just has zeros and ones, and what we have to do is we have to return the maximum length of the contiguous subarray that contains equal number of zeros and ones. So for example, here we have equal number of zeros and ones, right? So maximum length is 2. Here also it's 2, either you can consider this or 0 1. Here the maximum length is contiguous. Okay, the maximum length is 6. Okay, you can argue that okay, here is also contiguous and equal, but it's not maximum. The maximum is this. Okay, that's why it's 6. So that's a simple problem, and let's see the brute force solution. So what's the naive solution that one can think of? One thing is just have all the subarrays and then calculate zeros and ones in it. If they are equal, then just keep track of a variable called max length, which will be our answer or our output. And every time we calculate the subarrays, all subarrays, we will just update that max length if we are getting a maximum length as compared to the previous subarray that was calculated, right? So that's a simple brute force solution, and of course it will be O of n square. So let me explain that. So this is the same example that I showed you, and what I mean is we will start from here. This will be our first subarray, then second subarray, then third subarray, and every subarray will start from 0 first, then we will start all subarray from here, right? So this is how the nested iteration will work, and that's why it will be O of n square time complexity. And since we are not using any extra space, the space will be O of 1. Okay, so what I mean is it's simply that, for example, we start from 0 and this will be our first subarray. Then we will calculate whether this subarray has equal number of zeros and ones or not. So how we can calculate equal number of zeros and ones? We can just keep track of a variable which counts 0 and another variable which counts 1. And then what we can do is we can check whether that two values of the variables are equal or not. But that will be a bit tedious. But rather what we can do is just consider 0 as -1. So because just we have two values, right? So just have the prefix sum. So the sum until here is -1. Then here the sum is 0. Okay. So this is how, what I mean, why this is needed, because let me explain that. Let's say I have -1 here, then it will be 0 because we are getting +1, then it will be 1, then 2, then 3, then 4. Now we are getting 0. So it will be again decreasing by 1. Correct. So what's the intuition? The intuition is, if you will notice, here and here we are getting the same prefix sum. So this is prefix sum, or I can say running sum. Let's call it running sum, R sum. This is my running sum, and these two values have same running sum. And what does it mean? It means that in between we are having equal number of zeros and ones, because there is an equal increment and decrement happening, and that's why we can conclude that this much, right? So we have to exclude this one but include this last one. Okay, so this much array will be balanced, or it has equal number of zeros and ones. So simply in mathematical term we can say that, let's say this value is a and let's say this value is b, then we can easily calculate c as a minus b, and that's what we are doing here, right? We have values until here, we have the total value until here, we are just calculating this much. Okay, so we can easily calculate this much. So that's the simple intuition. So let's code it out, that what I mean, and I hope the things are clear that why this running sum will be helpful, correct? So, and this is a pattern which will be helpful in many of the examples. So this is the simplest one, because we have zeros and ones, and that's why I took it. So let's keep track of max length variable. Let's say it's 0. You can also have -infinity, but I think 0 is also fine. We will start with first, okay, element. So we will go until length of nums, and then we will go. So what I did is I just fixed first for loop will be fixing the first element, and then we will, from first element we will go until the end. So we have to go from first element, and that's why we will again go from I until length of nums. Okay, and obviously after every element we have to reset our running sum. So we will start our running sum from 0. Okay, and whatever value we encounter, based on that we will either decrease or increase. So it's not like we are explicitly replacing zeros with -1. What we will do is, if we are encountering 0, then our running sum we will decrease, and obviously if it's 1, then our running sum should be increased. And at the end what we will do is we will compare if my running sum equals 0. If it's 0, then we will update our max length variable as we will consider maximum of whatever is the previous value. And how we'll calculate the current value, let's see that on a board. So let's say, for example, I came to this point, okay, and now we are checking all the nested iterations from here. So all the subarrays from this point. Okay, so we know that this value and this prefix sum, it's the same. Okay, so in this array the prefix sum will be 0 at the end. Okay, when we reach to the very last point, then the prefix sum will be the same, right? So and the max value will be 6. So how we will calculate that value will be 6? It should be whatever is the jth value, so it will be j, whatever is the ith value, which will be 3, so it will be 8 minus 3, and we have to do plus 1. So 8 minus 3 is 5, but if you will see that this is of length 6, 3 ones and 3 zeros, right? Why? Because we started from, because this is included, 3 is included, okay, in our length. Okay, so if we go from 3 to 8, we just have to add 5. So it should not be length 5, because we have to include the starting position as well, and that's why we need this. So it should be j minus I plus 1. Okay, so what will be the maximum length? It would be j minus I, and we have to do plus 1 to include that. Okay, and then at the end we have to return our max length, and I think it should work. Okay, it's working, but it will give time limit exceeded. Okay, because it's a brute force solution, nested iteration. So it's not wrong, it worked for small length inputs. So let me write the time. So it's of n square, and space, we are not using any extra space except some variables, so it should be constant. Now let's optimize this, and this is really important, that we will make use of hash map. Now why hash map? Let me explain it nicely on a whiteboard. So for example, the same thing we are going to utilize, the prefix sum, and that's why I showed you this. Rather than keeping track of variables to count zeros and ones, you can easily keep track using the prefix sum or the running sum. So how this can be useful, and how combining this with the hash map can be a really good thing. Okay, so what we will do is we will store our running sum with the index value. So for example, we are getting running sum as -1, and we are getting it at index 0. Okay, so this is what we are gonna store like this. But why storing it like this? Because we need whatever is the first index or the first occurrence where this running sum has occurred. Now if this -1 will occur like again somewhere down the array, then what I'll do is I'll subtract that particular index where -1 will again occur with this index, and I'll get the maximum value, right? Because these are the index subtraction that we are doing. So that's why we are storing it in a dictionary. Okay, so just store simply. There will be one edge case that will be missed, which I'll explain later, but let's store it first. So we are getting 0 at the first index, and we are getting 1 at the second index, then 2 at third index, 3 at fourth index, then 4 at 5th index, then again 3 at 6th index, then again 2 at 7th index, and again 1 at 8th index. So now what we'll do is, firstly I'll just update my running sum like this. So let me try to code side by side. So it's almost similar to this. So let me copy this, and obviously we won't need that nested iteration. So we'll modify accordingly. But firstly, what I have to do is I'll just need one. Okay, so I won't need this nested iteration, and everything should be shifted. So firstly, let's create a hash map. Oops, hash map, and let it be empty, but there will be edge case that will be missed. But I'll show you deliberately that's edge case. And now the running sum, we don't have to update it every time. So it should be outside. Now what we have to do, again, if now we have to change to I. If my I is 0 and we don't need this because there is no j, we need this, but let's see when we will need it and how we will use it. Okay, so until now what we have to do, we have just one hash map which will update based on whatever running sum I'm getting. So if my value is 0, we decrease or we increase, and then we will update in the hash map. But as I said, we have to store just the first occurrence. Okay, it's not like we have to store all the occurrence, we have to just store the first occurrence. So we will see if my running sum is not in hash map, then only we will store. This will take into account the first occurrence. Then what I'll do is, my hash map of running sum should be that particular index. So let me write only store first occurrence. Why? Because we need maximum length, and maximum length can be calculated only when we store the first occurrence. Okay, and what if it's already in the hash map? Okay, then it's time to calculate the max length. So what will be the max length? It should be again the same, maximum of my max length. And now what will be the index that I have to subtract? Here is no j now. What I have to do, I have to check in the hash map, because it's already in the hash map, what's its first occurrence, right? And then we are good to go. But we will miss one edge case in some hidden cases. Let me make that mistake, and then we will correct it. Okay, so yeah, this thing, we are missing it. It's not even catching the very first thing. And why? Let's see that with the really small example. For here as well only, let's see that. So what we are doing, we are making a hash map. And as I said, what will be the running sum? The running sum will be, here it's -1 and here it's 0. So this is running sum. So we are storing running sum, -1 is index. So let me write, this is index and this is running sum. And we are getting 0 as running sum at index 1. Now, what's happening? Let's try run a really small thing. That here we are getting running sum as 0, and here we are getting it running sum as -1. There is no repeat of any running sum. But visually you can see it's a balanced array of length 2, right? So what is being missed? Something is missed, right? And what is missing is that let's have one running sum which is 0 at index -1. Can we consider this as index -1? So what we have to do is, we have to always put one entry of index -1. Let me draw it again, that we have to always put, because we just assume that our array didn't start it. So running sum is 0. Okay, nothing is started yet. Okay, so our running sum is 0 and it occurs at some dummy index. This is hypothetical index. So our array is this much only. It starts from index 0. but we are using one dummy index of index -1. Okay, because index -1 and the running sum is 0 because we have no element, so the sum is 0, nothing. And then we will put usual our two things. Now if you will notice, then you will see that okay, my running sum is 0 is already there. At which index? It's -1, so we can't store it again, it's already there, right? So whenever I encounter this running sum 0 again, then what we will see, okay, it's already there and we are encountering it at index 1. So what I'll do is I'll just use the value from here that it has already occurred at index -1, hypothetical index -1. So it should be subtracted from the current index minus the value from the hash map. This is the first occurrence of running sum 0. So it's not like this is the first occurrence. First occurrence is this dummy occurrence. And that's why we are getting 2. And that's what we are doing actually in our code as well. You can see here that I am using that dummy. So let me add that dummy. That is my running sum is 0 at index -1. And let me write its running sum and index, key and value. And if I'll run this, it works. Submit it, it works. And what will be the time complexity? Since we are iterating once, so it will be O of n, but the space as well will be O of n. Okay, because we are storing, in worst case, we will store all the index. Let's say we have just all ones, then we are just increasing, or all zeros, decreasing, right? Then we will have the running sum. All values will be unique. And in the worst case, it will be O of n, the space. So time and space both will be O of n. And you can check as well. Here, you can see it's the time and it's the space. So that's it about the video, and really useful pattern. So we'll stay tuned and we'll see the very next problem on the same prefix sum array, which is count the total number of sub arrays that makes to summation k or something. Okay, so we will see that soon. So stay tuned and